All right, guys. So let's talk about this hypothesis. I knew that we would kind of go a little bit crazy with it, just because of how crazy our definitions um, of best were. So um, remember, with best, we said it in the video a bit ago that you're really only looking at one variable at a time. So in our hypothesis, we also only need to be dealing with one variable at a time. Now, I see some hypotheses in the discussions that are very detailed and have some really good aspects to them. But really, for this experiment, if we're trying to figure out what the best plane is, we need to define one variable at a time, see which of those variables is the best, and then that could lead to further exploration. So those of you that are getting a little too ahead of yourselves and want to look at number of folds, wing size, all that kind of stuff as a predictor of how far a plane might fly or how acrobatic it might be or whatever, we need to separate that out. So we need to narrow it down to just one variable that then will help us gather data and collect that data and determine which plane is the best. So I'm going to use the example of flies the furthest, so covering horizontal distance, so the furthest from the thrower to a point on the ground elsewhere would be what I'm referring to as distance, so not distance straight up in the air or something like that. So if the best plane is the one that flies the furthest, then basically my hypothesis needs to address the type of plane and then how far that plane will travel. Now, if we were getting into more experimental design variables that might test other possible variables beyond that, then our hypothesis might be a little bit more lengthy. But because ours is just a simple observational quick experiment that's testing out the one variable to determine which is best, which then could open up to other ideas, we're going to keep it simple on this. So notice that a good hypothesis here needs to address the dependent and independent variables in an experiment. If you were in class, I would ask you right now which one is which, but you're not here. Dependent versus independent. I always think of independent. I starts with I can change it. As the experimenter, I can decide what happens with it. Then dependent depends on what I do. So in this case, that might be a little hard to see, but I am changing the type of plane that is flying. So independent is the type of plane in this experiment. And the dependent is how far that plane goes. Now, those are my two variables. So in my hypothesis, I need to have something about that. So is it feasible? That just means is it not crazy, out of this world type stuff? So is it within the realm of natural world possibilities? Yes. If I throw an airplane, depending on how far it goes, that can tell me if it's the best plane or not, right? So is it testable? Yes, I can collect data on this and I can figure out. While we're on that subject, if I decided to do best airplane is looks, right? Then obviously I'm going to have a different type of data. That's an objective type thing, so I would have to turn that objective, opinionated data into more subjective data, as that were, and we'll talk about that a little bit later. Is it clearly written? So if we use like if-then statements or cause and effect type relationships, it should be pretty clearly written. Now, if we get into more detailed scientific experiments, sometimes we talk about null hypotheses and variables that could affect things, and then to what degree it could cause correlations. This one, we're basically correlating how far the plane goes to best. So really our correlation is going to be relatively simple this time, or it should be. And then this is a big one here. We want to eliminate bias. So bias is where we lean toward an outcome. So I already noticed in some of your posts, you're referring to certain planes as my plane, or you're saying the heavier plane feels like it will go further, or it has better folds so it will go further. You're getting into the game of a hypothesis being a educated guess, right? And I have a little bit of a problem with that, because we don't want it to be an educated guess, because when you have an educated guess, you have stake in the problem. So for example, I've heard the hypothesis is like guessing how many jelly beans are in a jar, and then you don't know until you count. So the experiment is the counting part, but the hypothesis is your guess of how many are in the jar. Well, really, your hypothesis isn't the guess of how many are in the jar. Your hypothesis would be something along the lines of, if I can calculate how many jelly beans, or if I can calculate the volume of a jelly bean, then I should be able to determine the volume of the jar and correlate this to how many beans are in the jar. That takes the bias out of the experiment. That means that we're actually doing the experiment to determine what that shows us. So I would have a good guess because I had to do an action to come to that point. If I am saying that I think my plane will go further, then I'm saying that I like my plane and I want it to go further, which when you throw that plane, now you're going to probably try to make it go further. So you got to be real careful about bias. Bias basically means that you are trying to put your feelings into the situation, and that could ultimately affect the outcome of your experiment. So you have to be real careful about bias. You can actually see a lot of this going on right now in the hunt for a cure for COVID. A lot of places are basically saying that their treatment trial is going to be better than someone else's, or whatever. Really, that's not, or their vaccine is better than others. That's not really the goal. The goal is to find the vaccine that works the best. And if we've got someone who has way more money, then they can bias that towards making their treatment get pushed through, even though it may not be the best for everyone. So if you wrote something like, if you made a prediction basically on which plane will be the best, you are being biased. You need to let the data be the data. You need to let the outcome be the outcome. So instead of saying which plane you think will be the best, you just need to state simply that the plane that travels the furthest will be the best. So you would kind of word that into, if 3 different planes are flown, the plane that travels the furthest will be considered, or on average travels the furthest, will be considered the best. So simplify it. Try not to put your own opinions into it, and try not to make it where someone could look at it from the outside and say, well, you wanted that plane to win, so that's why that plane won. So keep bias out of it. Then the last one here is basically what I want you to do with your hypothesis. This one is a hard hypothesis to write because it needs to be so simple. So really, your hypothesis needs to be something along the lines of if 3 paper airplanes are of different types are thrown with equal force, which you need to sort that out. Equal force could be biased. If you're throwing one harder than the other, that's technically an experimental bias that you're adding to it. So fix that. So if 3 planes are thrown with equal force, the plane that travels the furthest will be the best, and that's basically your hypothesis for this experiment. Now, what could that lead to? That could lead to another experiment down the road that says, well, why is, plane X? Why did it travel further? Why was it the best? And then you might have to explore several different variables. Then you might get into folds or wing sizes or things like that. So for now, ours is simply determining which one is the best. So if we throw 3 different types of planes with equal force, the plane that travels the furthest will be the best, or is the best. And that's basically where we need to leave it. So what I need you to do now, go back, fix your hypothesis on your reply. That's going to basically give me a place to just look at it, make sure that you get what I'm talking about, make it simple, right? If you want to use what I said, fair enough. Might be good enough. It's an if-then, straight to the point, both variables. Do it. But go back, post to your post with a reply that fixes your hypothesis as you want to write it later on when we actually turn this into a written report. And then you might go on and just look at some other people's and see how they changed what they changed. And then if you want to reply or post or ask questions about why they did what they did, feel free. But I'm not looking for you to reply to anybody else's posts. I just want to look at how you fixed yours so that I can then reply to you specifically if we need to. So that's that. Take care of that, and then come back here for the next part.